Okay, we start our series for primary school teachers and our adult community on how they can talk to their children about universe and the big picture of the universe should be a bit clear to us. We'll talk about the universe itself as our understanding developed about it, and we've heard about that there are galaxies in the skies and the space. The galaxy that we are in is the Milky Way galaxy. The one galaxy is a big thing. It's a billions of stars in one galaxy, and about 100 billion in our Milky Way galaxy. Our sun is a very, 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 very tiny part of it. The sun and its family, we call it solar system, and Earth is one of those nine planets, eight or nine planets which are in the solar system. So that's how it is. We have heard about that it was created somehow, as we understand, in an explosive way, Big Bang. Uh, I always relate my experience because that is an experience of everybody, most of us around who were in schools. Nobody bothered, even at the university level, for even a couple of moments. What is this Big Bang and what is it about? When did it happen? Not a single paragraph in all 16 years of science education came in the curriculum. That was totally ridiculous. So that's why we said, no, these are this is a common knowledge now, and this should translate into our daily life talks and our schools. So there are three forces and three particles. That's all we know about the universe, and we'll know a little bit more about it. And it's the starting point that there are three forces and three particles which make the matter. The forces are gravity, electromagnetism, and strong nuclear force. And the particles are, we call them subparticles, of which this matter that we touch and see is made of leptons, quarks, and bosons. So let's see a little bit more on it. And a little bit more on it is that, as we know, that everything is energy or matter, right? Matter is, in fact, a condensed form of energy. So it's a matter or energy, they are interconvertible. And that's how it happens when an atom bomb explodes. And that's what's happening in the sun. And everything matter is made up of about 92 or a little bit more, now 100 plus different elements. Elements mean something in the pure form, like gold, like oxygen is an element, iron is an element. So there are different forms, liquid, solid, some gaseous. We'll talk later as we move forward. And everything in the matter form is made of very, very, very tiny particles, which we call atom. The word atom came from that it's indivisible. But later we discovered that no, there are a lot of subparticles within an atom, and atoms combine themselves to make molecules, right? The simplest of the atom is hydrogen, and this chart that we often see in our chemistry books normally, it shows every pure element as such. Uh, and atom is now divisible, and that's what's happening in a nuclear reaction and in happening in the sun, that atom breaks and atoms can combine, etc. But our question essentially is, where did it all came from? So if, what if child asks, where did this sun came from, and where did this earth came from, where did we human beings and everything came from? So there is a big history, and then we drill down into it. It's a very simple and a big view that we have to take, and things are obviously very interesting and miraculous, and very little understood by humans so far, in fact. A very first thing that comes into mind in the science is, can anything be created from nothing if there was nothing in the beginning? And obviously, the science answer used to be, no, no, nothing cannot create anything. So if there is something, it came from something. So the matter is eternal and these sort of stuff a human being used to think. And now our understanding is, nah, no, 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 it happened, there was nothing, and out of it some energy starts coming in, about 14 billion, rough estimate is 13.8 billion uh, years ago. So that nothing, we have coined a name for that, singularity. So means what? That everything that we now see around us, all matter and energy and whatever space and planets out there, they were all in uh, less than a point space. It was all condensed, and now the science has a very revealing facts that even in the first second, scientists have sliced it into trillion parts, and we now have an observational understanding which might change after some time. But today's understanding is that on the 10 raised to power 1 million trillionth of a second, some energy particles started appearing from that singularity. And in about uh, after some time, universe started doubling itself, and it doubled in every million, 5 times millionth of a second. It was doubling. Now our mind even can't perceive what this sort of doubling, which lasted only for 1 over 10 raised to power 30, mean 30 zeros, a very tiny fraction. But that doubling, I'll, to give it an idea, I a little bit did of doubling maths for you, and we'll see in the next slide. See, if we double, let's say, a carpet or a paper which is 1 millimeter only. I have converted that 1 millimeter in the beginning to a kilometer so that eventually it looks like in the kilometer. If we double it twice, once obviously it becomes double, and the next time it will become 4, and next fold it becomes 8, and we fold it once more, it becomes 16. If we keep on folding it and keep on doubling it, in 25th fold we reach the atmosphere, which is about 17 kilometers, the end of the atmosphere. And imagine in 40th fold we cross the moon is about 400,000 kilometers out there, and we cross 500,000. And in 49th we cross the sun is in fact 150 kilometers, a million kilometers, and our 49th fold is 280, kind of double the sun we are out. And in 64th fold we covered the distance, the same carpet will be as fat as 1 light year, the distance which light covers in 1 year. And light is extremely fast, 300,000 kilometer per second, not per hour, per second, 300,000 kilometer per second. And it, further few folds, now every fold has become gigantic and a big one really. 71st fold, we are 124 light years, and our Milky Way galaxy is 100 light years. 100 light years means it's so big, in fact, that if on one part we make a call hello, this will reach the other side in 100 years, right? The light comes to us from sun in 8 minutes and 26 seconds. That's all. Light only takes about less than 8.5 minutes. So in 71st fold, we are as far as the center of the Milky Way galaxy. And imagine in the 100th fold, we are uh, 66 billion light years, and our visible universe, which we can see, is only less than 47 billion light years. So we have crossed that. So doubling is that sort of stuff. Now let's go back to our slide. So it kept doubling, although it was a very tiny fraction of a second, 10 raised to power minus 30. Minus means 1 over 1, 10 raised to power 30. 10 raised to power 30 means 1 with 30 zeros. So it's a million, 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 million of a second. It kept doubling itself. So it grew to a tremendous size in a very tiny fraction of a second, which comes 10 million, 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 million times bigger than that tiny particles. And gravity, and all those forces, the three that we talked about, were obviously unified. And gravity decided, okay, guys, I am going out and I want to be separate. And gravity, a 10 millionth of a trillionth of a trillionth of a trillionth of a second, the gravity detached itself and came as a separate identifiable force. And then came the electromagnetism and the strong nuclear forces later. And in less than 3 minutes, the entire matter and energy that was and was to be, that we observe and see, was created, finished. Unimaginable. It's a marvel, which human mind can't even kind of appreciate and perceive. And the total number of particles we estimate is in the region of 10 raised to power 80, 10 raised to power 82 particles. And initially there was matter, there was antimatter, etc. And matter and antimatter was discovered by Paul Dirac, a scientist. So many scientists came. We will talk about those heroes as well, and as we move. But now that matter and antimatter combined itself, and it annihilates, right? They just become the energy sort of. And the position now is only 4% of the universe is matter or energy that we can observe and see, which our instruments can detect, which our science is about. 96% of universe is what so far we know nothing about: the dark matter and dark energy. Dark matter means that if we take a part of the universe and we measure its weight and mass by our observation and by our mathematics, the real mass comes 4 times. So there is some dark matter out there which our instruments can't detect, but it exists. And the universe is expanding continuously, and it is expanding faster than the speed of the light. So there is some energy somewhere which is continuously pushing it far, and it's accelerating. So that energy is a dark energy. That's all sort of our understanding, roughly. So it's amazing in itself. And in the first atom, when the electrons sort of came to circle around the nucleus. The nucleus is the inner part of that small particle, which is a positively charged, and outer side there are electron cloud, which is negatively charged. So since before that, initially the temperature was so great in trillion whatever of kelvins or centigrades, that in that temperature the particles could not live with each other, and temperature was cooling down. As we expand something, with the expansion things cool, right? And the universe was cooling at a tremendous rate, and at about 380,000 years it cooled down to a stage where the first atom was born. And that's a story. And it's amazing, isn't it? Now our understanding is that it's about 14.6 billion light years that we can see. Now, why? Reason is that that's the time it has elapsed since the Big Bang happened. But issue is that the universe is expanding more than speed of light. So what we can see depends on that the light travels to us. So whatever universe out there is expanding, we are not even able to see that. That light will never reach us. The light that would reach us is only to the extent of the speed of the light. The speed of the light is very crawling speed in the universe's big scales. So that's why the sky is dark, because we are at a corner and the rest of the universe is moving away from us. And this moving away from us with the speed of light, imagine a torch which is emitting out light, but the torch is moving more than the light itself, so its light is not coming back to us, so we are in the side of the dark. So are there any life around in the other planets? Our estimates are there are millions of lives out there by probability, and that's a Drake equation, which is there can be how many stars are being formed, and how many stars can be habitable by probability, and how many of them can have a life bearing environments and intelligent lives. And a bacteria type life, even if exists, that will not be able to communicate. So that's a Drake's equation, which it gives us sort of an idea that there are possible millions of them are possible, even more. But since the distances are so far, that communication which happens at the speed of light is very unlikely to happen unless we discover something which is more than speed of light, which so far our science does not. And the farther we go, the more is the speed of the galaxies receding away from each other. That's Hubble's formula, which is I have written HD. H is the Hubble constant, which gives an idea. If you can Google it or internet on, you can see the idea in which it's moving fast. So we are at a very tiny part somewhere, and we are even unaware what the total size is. That was a brief overview that there's a universe out there, and in the universe there are billions of galaxies. Our galaxy is one of them, which has about 100 billion stars. And very interestingly, so for the most complex thing, now, this is enormous in size, but in complexity, the most complex thing is human mind, which has about the same number of neurons, 100 billion. So it's a totally can be likened to a galaxy in itself. The human being is a universe. And these universes are being created by the creator every instance. We are in just one of those tinies, and now scientists call it the multi-universe theory, etc. And as the Iqbal said, ये कायनात अभी ना तमाम है शायद कि आ रही है तमादम सदाए कुन फयकून. So it's a interesting journey that we have started on the science, and this is what we should share with our students. And if we know a little bit about these things, we can talk much better and connect them much better to the science and their life. Thank you very much.